Let's solve some problems. Let's say we have to find the Laplace transform. Find Laplace transform of 2 sine 2t sine 5t by, okay. So again, the moment you see this, you should realize that you require some trigonometric identity. Okay, so here we have 2 sine A sine B. The identity that we can use is cos A minus B minus cos A plus B. So which means 2 sine 2t sine 5t is equal to cos 2t minus 5t minus cos 2t plus 5t or cos minus 3t minus cos 7t, or remember cos minus x is cos x, so cos 3t minus cos 7t. And let us say this is the function f of t. Okay, so the Laplace of f of t is equal to what? Now go to the table of Laplace transforms and you will notice that this is Laplace. Okay, let me write it as steps. Laplace of cos 3t minus Laplace of cos 7t, which is equal to s by s square plus 9 minus s by s square plus 49. So this is, let's say, capital F of s. So our Laplace transform of f of t by t, which is what we have to figure out Laplace transform of, is equal to, now if you remember the theorem that we saw in the previous session, this is an integral from s to infinity of capital F of s ds, which is equal to s to infinity integral of s by s square plus 9. We can split it, so ds minus integral from s to infinity of s by s square plus 49 ds. And this, now this would be log of s square plus 9. Now very quickly you do the differentiation to get back this. Differentiate log, so it becomes 1 by s square plus 9, right? And then you have to differentiate s square plus 9. So which gives us what? 2s. So the 2 extra we have got. So now let's make it 1 by 2 to cancel that. Similarly, now we can do what? 1 by 2 log of s square plus 49. This would be from s to infinity and s to infinity, which is equal to, now let's see, if 1 by 2, let's take it common out. Now here when we substitute infinity, this will become 0. Log of a large number becomes smaller and smaller, so it becomes 0. So 0 minus, when we substitute s, we don't really have to do much. So s square plus 9 minus 1 by 2, we have taken it out. This again, as it goes to infinity, this becomes a 0. Then minus into minus plus, we get log of s square plus 49. So 1 by 2, this is log of s square plus 9 plus log of s square plus 49. 1 by 2. And here what we can do is subtraction. It is this minus this, so that we can convert it into division. So log of s square plus 49 divided by s square plus 9. So that is the Laplace transform of f of t by t for the given f of t. Let's look at the second problem. Laplace of sine square t by t. Sine square t is equal to, again, trigonometric identities, 1 by 2 times 1 minus cos 2t. So which means we can treat this as f of t, 1 by 2 times 1 minus cos 2t. The Laplace transform of f of t is equal to 1 by 2 the Laplace of 1 minus cos 2t, which is equal to 1 by 2 Laplace of 1 minus Laplace of cos 2t, which is equal to 1 by 2 Laplace of 1 is 1 by s minus Laplace of cos 2t is s by s square plus 4. So Laplace of f of t by t would be equal to the integral from s to infinity of f of s ds. So here this is f of s, which is equal to integral from s to infinity of 1 by s minus s by s square plus 4 ds, which is equal to 1 by 2. We can differentiate this separately. This becomes 1 by s is log s minus 1 by 2 is common, so this becomes log of s square plus 4 from s to infinity. Okay, so 1 by 2 log of infinity is 0, so 0 minus log of infinity again 0, so we can ignore this. Log of s as it is, log of s minus log of s square plus 4. So this becomes 1 by 2. This becomes plus, this becomes minus. So let's exchange. So log of s square plus 4 minus log s, which is equal to 1 by 2 log of s square plus 4 by s. That is the Laplace of sine square t by t. Let's look at another problem. E to the power of minus at minus e to the power of minus bt by t. We have to find the Laplace transform of this. So again, let's say f of t is equal to e to the power of minus at minus e to the power of minus bt. So Laplace transform of f of t would be equal to, again, go back to your Laplace table, 1 by s plus a minus 1 by s plus b, and this is equal to f of s. And the Laplace transform of f of t by t is equal to the integral from s to infinity of f of s ds, which is equal to integral from s to infinity of 1 by s plus a minus 1 by s plus b ds. So let's integrate. We get log of s plus a minus log of s plus b from s to infinity. Okay, let's do the substitutions. Log infinity is 0 minus 0 minus log of s plus a minus log of s plus b. This becomes this becomes plus, this becomes minus, so log of s plus b minus log of s plus a, which can be written as log of s plus b by s plus a. So that is the Laplace transform of f of t by t, which is e to the power of minus a t minus e to the power of minus b t by t. So as you might have noticed, things become much more simpler. Now let's have some fun. Let's begin with this, right? So my next problem is the Laplace transform of f of t is equal to log of s plus b by s plus a. Okay, what we have to do is we have to figure out um, f of t. Okay, so f of s is equal to log of s plus b by s plus, which can be written as s plus b minus log of s plus a. Now f prime of s derivative is 1 by s plus b minus 1 by s plus a. Remember, Laplace of f of t is equal to f of s, which means if I take the inverse Laplace on both the sides, this gets cancelled. So I'm left with f of t is equal to Laplace inverse of f of capital F of s, which is equal to, remember, 1 by t Laplace inverse of f prime of s. You have to remember the theorems. And this is 1 by 1 by t Laplace inverse of 1 by s plus b minus 1 by s plus a. Yes, so minus 1 by t. Now Laplace inverse of this is what? E to the power of minus at. No, bt minus e to the power of minus at. And just so that we can read it properly, we can write it as e to the power of minus at minus e to the power of minus bt by t. Now, is this what we e to the power of minus at minus e to the power of minus bt by t? This is what, this is the function which we, whose transform, Laplace transform is this. So we did it both ways, one way and the reverse. Yes. Similarly, if we look at the next problem, Laplace of f of t is equal to log of s square plus 1 by s minus 1 square is equal to f of s. We have to find the Laplace. Sorry, we have to find the function. Laplace of this function is equal to this. So, which means we can write this as log of s square plus 1 minus log of s minus 1 square log of s square plus 1 minus 2 log s minus 1 f prime of s. Remember, this is f of s. We need to differentiate this. So this becomes what? 2s by s square plus 1 minus 2 by s minus 1. This is s. So f of t is equal to the Laplace inverse of capital F of, which is equal to minus 1 by t, based on the theorem, Laplace inverse of f prime of s, which is equal to minus 1 by t Laplace inverse of 2s by s square plus 1 minus 2 by s minus 1, which is equal to, now 2 is common to both, so we can take it out. So this becomes minus 2 by t Laplace inverse of 2s by s square plus 1 minus Laplace inverse of 2 No, 2 is not there, we have taken it out. So 1 by s minus 1 minus 2 by t, and now go back to your table. So this gives us cos t minus this gives us e to the power of t. Now we can take this minus inside. So 2 by t is equal to e to the power of t minus cos t. And finally, let's do one more problem. F of s. Remember, capital F means it is the Laplace. So s log of s plus 1 by s minus 1 plus 2. What do we have to do? We have to find the function. So f of t is equal to what? So s times log of s plus 1 minus log of s minus 1 plus 2. F prime of s is equal to s times log of s plus 1 is 1 by s plus 1 minus 1 by s minus 1, right? This is one function, this is the second function. So product rule we are applying to differentiate. So s as it is and the differentiation of this will become 0. And then minus, now differentiate s, that is 1 log of s plus 1 minus log of s minus 1, this as it is. Now s times 1 by s plus 1 minus 1 by s minus 1 minus, this can be written as log of s plus 1 by s minus 1, which is equal to s times s minus 1 minus s minus 1 by s plus 1 times s minus 1 minus log of s plus 1 by s minus 1. This becomes s times s and s gets cancelled minus 2 by s square minus 1 minus log of s plus 1 by s minus 1. So this becomes minus 2s by s square minus 1, and this should be plus log of s plus 1 by s minus 1. Now, which means we have to figure out where this mistake has been made. And uh, if you notice, I applied the product rule here. So here s as it is, then the differentiation of this, then should come plus. In the quotient rule we have minus, but here in the product rule we have plus, and then we differentiate s and leave this as it is. So that is one mistake. Okay, so this is f prime of s. So now what do we require? We require f of t. So f of t is equal to the Laplace transform of the inverse Laplace of capital F of s, which is equal to minus 1 by t Laplace inverse of f prime of s. So here f of t equal to Laplace transform. This is straightforward. But now we are applying that theorem. So minus 1 by t Laplace inverse of f prime of s. So which means what? This becomes 1 by t the Laplace inverse of minus 2s by s square minus 1 plus log of s plus 1 by s minus 1, which is equal to minus 1 by t. Let's take minus inside. So if we take minus inside, it becomes Laplace inverse of 2s by s square minus 1 minus log of s plus 1 by s minus 1, 1 by t, and Laplace inverse of this would be cos minus e to the power of t minus e to the power of minus t by t. Okay, good bit. Now let's take 2 out. So 2 by t cos t minus e to the power of t minus e to the power of minus t by, remember we took 2 out. In this case there is no 2, so we have to divide it by 2 t. Not required. We can actually take t also out. Yes, so this becomes 2 by t square if we take one more t out. Now here there is no t, so we have to multiply. So t cos t. So now if you multiply it, one of the t's get cancelled and you're left with a single t. Minus e to the power of t minus e to the power of minus t by 2. The reason we did all this is to get this t cos of t minus hyperbolic sign of t, to get this, so that we could write this. Okay, I think you got the idea. Practice. Bye for now.